Okay, now we're going to talk about product rule and quotient rule. Product rule means multiplication. So if I've got a function y equals u times v, then I can use the product rule. There's a derivation of how this works in the textbook, but how the product rule works is I can figure out the derivative, and the derivative is going to be equal to the value of u times the derivative of v plus v times the derivative of u. I'm going to call this u prime. Now, I don't know why calculus people use the letters U and V, because it's so easy to switch them up accidentally if you're a sloppy handwriter, but oh well, that's how it works. Professor Dave uses F and G. I think that's really confusing, so I'm just going to cover this and pretend that they didn't do this. But this first example here is in the Professor Dave. You may want to ask him. You may want to watch and see how he does this. So anyways, so here I would say, so we've got a product here, this times this. So using the product rule, I could say u is equal to x cubed, and v is equal to 2x. So now I can take the derivative of u, so I'm going to call this u prime, and the derivative of x cubed is 3x squared, and the derivative of v is simply 2. Okay, so using this formula, I'm going to say, I'm just going to call it y prime, is equal to u, which is x cubed, times v prime, which is 2, plus v, which is 2x, times u prime, which is 3x squared. Okay, and I can simplify that, and I get 2x cubed plus 2 times 3 is 6x cubed. And that simplifies to 8x cubed. Now, I'm going to show this the old-fashioned way. Let's pretend that, because this was really easy, I could have said that f of x is simply x cubed times 2x. That gives me 2x to the fourth. Does that make sense? X cubed times x is going to give me x to the fourth and 2. So we could have simply just multiplied those two together, and then I could have used the power rule, and then I say 4 times 2 gives me 8. This decreases by 1, and there's my f prime. And notice we have the same answer. Can't write. Okay, so this just showed that this actually works. So let's do an example with some things that are a little bit trickier. Okay, so this is example 12 from your Oxford textbook. They want you to use the product rule to find the derivative. I'm going to zoom in so you can see it a little better. So I can say that u equals x squared plus 2x, and I'm going to say that v equals 1 over x plus 3. So I'm going to rewrite this because I don't like seeing the x in the denominator like that. So I'm just going to say v is equal to x to the negative 1 plus 3. Okay, so that I don't have to have that fraction denominator thing going on. Okay, so u prime is equal to 2x plus 2, right? So I've taken the derivative of that. V prime, so power gets multiplied to the front, negative 1, and then this power decreases by 1, so this is negative 2. Okay, so I've got my derivative of v, and the derivative of 3, it's a constant, so it goes away. Okay, so once again, our formula, it's right up here, u times v prime plus v times u prime. Okay, so let's substitute it in. So y prime equals u, which is x squared plus 2x. V prime is negative x to the negative 2, right? Okay, plus v, which is x to the negative 1 plus 3. Don't forget your parentheses. If I didn't put that in parentheses, we may have a PEMDAS error. Okay, u prime is there. 2x plus 2. Okay, so now we can simplify this a little bit. I could say this is equal to x squared times negative x squared plus 2x times negative x squared, right? If I did distributive property with a negative 1 over x squared, and then here I could FOIL this out. That times that gets me 2x over x. This times that gets me 2 over x. That times that gets me 3x. And that times that gets me plus 6. Okay, so now we can simplify this a little further. This becomes negative 1. This becomes 2. This becomes negative 2 over x. And then plus 2 over x plus 3x plus 6. Okay, and then I notice negative 2 over x, positive 2 over x. That's going to cancel out. And then now I can combine the like terms. Negative 1 plus 2 plus 5 is going to give me 7. And then we've got 3x. Dun, da, da, da. Okay, that was a fun example. Whee! Okay, so let's do this other one. Oh my gosh, this answer looks insane. Okay, so I would say u is equal to x squared minus 4 squared. V is equal to x cubed minus 1 to the 4th. So we have to use product rule to do this. We're also going to need to use some chain rule going on. So we could say du dx is equal to 2 comes to the front times x squared minus 4. And then the derivative of x squared minus 4 is 2x. Okay, so I just did a little bit of chain rule in my head, which is the 2, pretend this whole thing here, pretend this is u. So the derivative of u squared is 2u, and then times the derivative of u, which is 2x. You may want to hit rewind and think about that some more. So same thing here, dv dx. So think of this as u. So then I would have 4u cubed. U is x cubed minus 1. And then the derivative of u, which is the yellow thing, the derivative of that is 3x squared. Okay, so this here simplifies to, I'm going to write this u prime, 4x 4. And this here simplifies to 12x squared times x cubed minus 1 cubed. Okay, so what colors am I going to use? Okay, so I'm going to make this be equal to this, and I'm going to make this equal to this. Okay, so what we've got here is this is u prime, this is u. This is v, and this is v prime. Okay, so our formula is u times v prime plus v times u prime. Okay, so here's my u times v prime. V prime is this plus v times u prime. Okay. So what did we just say? We said y equals u times v prime plus v times u prime. That's what we just did here. Okay, I hope my color coding makes sense. You might want to hit pause. Okay. So the next ones I've already solved out, but I'm just going to use highlighters to help you out. Okay, so now we're going to talk about quotient rule. I'm just going to do it because I don't want to give it away yet. Okay, so quotient rule has this formula, and it looks kind of messy like this. So I'm just going to rewrite it here as y, the derivative of y is equal to v times u prime minus u times v prime divided by v squared. Now, I've been doing quotient rule for a long time, and it's so easy to get the ones mixed up because of this minus sign. With the product rule, it doesn't really matter because you're adding in between the two, right? But with the quotient rule, we've got the subtraction thing going. So make sure you label everything very carefully. So what I mean is, so like here, I'm going to say u is the thing on the top, right? So u is equal to x squared plus 1. V is the thing in the denominator. V is equal to x plus 2. So now the derivative of u, I'm going to say, is equal to 2x. The derivative of v is equal to 1. Okay, so I'm going to use the same color coding I just did on the previous page. So here's my u prime, here's my v, and here's my v prime. So v prime, v squared, u prime, u. Okay, so I'm going to do it just like I did up here. So I think the color coding will help. So let's do this here. Okay, so v times u prime. So x plus 2 times 2x minus u times v prime. So x squared plus 1 times v prime, which is 1. Okay, divided by v squared. Oh, I didn't put a little prime there. Should have done it. V squared is x plus 2 squared. Okay, so this was v squared, this was v, this is the derivative of v, this is u prime, and this is u. Okay, I wouldn't say you don't necessarily need to highlight all of them, but maybe one or two like this, and that would help you at least get started with this whole process. Okay, so now we can simplify this out. So let's multiply it through. So then I get y prime is equal to 2x squared plus 4x minus x squared minus 1 divided by x plus 2 squared. Okay, I can combine the like terms, and then I get 2x squared minus x squared is simply x squared, and 4 plus 4x, and then minus 1, all divided by x plus 2 squared. Okay, that's the quotient rule. Okay, so I've already solved the next ones out, but I'm going to do it with the color coding that we just did. Okay, so I'm going to put that formula with the highlighted colors right up here. Okay, so and all of these formulas are on the formula sheet. As you can see, there's some other ones we're going to do: sine, cosine, tangent, e to the power of x, natural log of x. So we've got our product rule and quotient rule right here. You don't need to memorize it. Okay, so here we've said that u is x squared plus 3. So the derivative of that is 2x. V is my denominator, which is x plus 1. Oops. And my derivative of that is 1. So using this formula, we've got v and the derivative of v and the derivative of u minus u. Okay. And then I do distributive property with this 2x. I get that. The distributive property with the 1, and I get this. And it simplifies to this. Okay, oh, I love this question. Find the tangent line. They should write tangent line. Okay, so that's when you've got a curve and you have a point and it cuts through. So we've got this equation here, right? This equation is the derivative. So at this point, the derivative gives us the slope, right? So at this point of -2, I'm going to plug in -2 in for x for my equation here. So instead of x squared plus 2x minus 3, I'm going to have -2 squared plus 2 times -2 minus 3. I'm replacing x. I'm replacing x with -2 from this equation here. Okay, simplifies to this. So now I've got my slope. So my slope is -3. Okay. And then using point slope form, I can figure out the equation of my line. I've plugged in -7 in place of y. I've plugged in -2 in place of x1. Distributive property with that -3. You might make a sign error if you're not careful, because this is minus and -2. So that's going to be +2, but then -3 times +2 gives me -6. Okay, add 7 on both sides. There it is. Okay, let's do the next one. Okay, now they want you to find the normal. So don't forget, if my slope is -3, that means my perpendicular slope is the opposite sign and the reciprocal. So the normal slope to -3 is 1/3. So same as what we just did, except I'm using 1/3 instead of 3. Okay. The last couple of problems in this packet involve tangents and normals. There's definitely going to be something like that on the test, so don't skip those problems. There's a lot of problems on here, so I probably should have removed some of the problems, but I'm going to put this up here. You can hit pause. Okay. Oops, I guess you can't see this whole thing. Okay. You don't need to do the whole thing, as long as you understand. So, excuse me. As long as you can understand some of the quotient rule and some of the product rule questions, then we're good. Okay. So, V. Right. Same process. Okay. Like I said, if you do 2 or 3 of these, then you should be good. And these bottom ones are kind of crazy. You don't necessarily need to do those, but they're there for you. Okay. And here was just some mixed review. Like I said, you don't need to do all of these. It's the last 2 problems that I most want you to focus on. So C and E are quite a doozy. Okay, like I said, you might want to hit pause. You don't necessarily need to do all of those. Okay. So we have point P is right there. Find the derivative, and so we're going to use the product rule, right? And questions 4 and 5. Is there 6? I don't remember. But those are the type of things they'll ask on a test. Okay. I guess it's just 4 and 5. Okay. So, and hence find the equation of the tangent line. So this tangent line is like this guy here. It's basically a line that touches this at one point, and it's there. Okay, so the normal line would be perpendicular. Okay. Okay. The scale's funny, so it's not going to look 90 degrees, but it's supposed to be 90 degrees if the scale of the y was the same as the x. Okay. because the scale is so funky, don't worry about this area question here. Let's do question 5. Same sort of thing. Um, uh, Find the equation of the normal. So step 1, we found the derivative, and um, so this is the derivative, and then we've got this point 2, so we're going to plug 2 in place of x for our derivative, and then we end up with 6 over 2 plus 3 is 9, 9 squared, which is this. So this tells me that my slope is 6 over 9, or 2/3, right? So the perpendicular slope is going to be 9 over 6, and opposite sign, so which simplifies to negative 1.5. Okay, so now I'm going to use negative 1.5 for my slope because we're trying to figure out a normal equation. And I do distributive property with the negative 1.5, and then I add 2 on both sides to get my equation. That's my equation of the normal. Question B says find the coordinates of the second point that intersects. So if I graphed this, the y equals 4x minus 2, all divided by 1, you're going to get something that looks like this. Okay, it's a curve here, and then to find out where the normal intersects the line, again, it's right there. So I would use my calculator and get that answer. And that is it for this lesson.